Welcome back, guys. I'm करेंगे dynamics question 6, paper 2. Question 6, figure 2.1 shows the thinking distance and the braking distance for a car driven at 100 kilometers an hour. The car has old, smooth tires. गाड़ी के पास old and smooth tires है. जब गाड़ी के टायर्स पुराने हो जाते हैं ना, they start to lose their friction. The friction they have between the road and the tires, right? क्योंकि शुरू शुरू में नए टायर्स होते हैं उनके अंदर एक डिजाइन सा बना होता है. इट्स टू मैक्सिमाइज द फ्रिक्शन. बट आहिस्ता आहिस्ता जब वो टायर घिस जाते हैं ना तो उनका वो डिजाइन जो होता है वो रिमूव होने लग जाता है. वो इक्वल आउट होने लग जाता है विद द अदर पार्ट्स ऑफ द टायर. सो दैट मेक्स द टायर ओल्ड एंड स्मूथ. एंड अगर स्मूथ होंगे तो देर विल बी मोर स्लिपेज एंड देर विल बी अ ग्रेटर ब्रेकिंग डिस्टेंस. Anyways, calculate the total stopping distance for the car. Stopping distance will consist of thinking distance and the braking distance. Just imagine you're going on a road और आप आगे एक बकरा देख लेते हो. पहले आप सोचोगे ये बकरा सामने है, I should stop. पहले आप सोचोगे ये, right? पहले आपके दिमाग में जाएगा. So it will take a couple seconds for you to think, and then you'll start to apply the brakes, right? Then you'll start to apply the brakes, which is the braking distance. So the total time to the total time to stop will include the braking distance and the thinking distance, both. 21 plus 75 will give us 96 meters. This is the stopping distance. The car is now fitted with new tires. New tires matlab the braking distance will reduce. ठीक है ना, braking distance will reduce. आगे at a speed greater than 100 kilometers an hour, the total stopping distance is the same as in A. State and explain the effects effect that the increase in speed and the use of new tires have on the thinking distance. The use of new tires will only affect the braking distance, not the thinking distance. Distance will totally be dependent on the speed. Because, for example, आप गाड़ी पे जा रहे हो, sometimes you don't have आपकी स्पीड बहुत ज्यादा होती है for you to think in that time. आप गाड़ी पे जा रहे होते हो, आप 100 किलोमीटर एन आवर पे जा रहे हो, राइट? एंड आपके सामने एक बकरी आ जाती है. आपने सोच लिया और आप अप्लाई करने लगते हो ब्रेक, तो आपकी बकरी मर जाती है. लेकिन आप 10 मीटर्स पर सेकंड 10 किलोमीटर एन आवर पे जा रहे होगे, तो यू विल हैव मोर देन एनफ टाइम टू थिंक एंड टू इम्प्लीमेंट द चेंज. आप मतलब ब्रेक कर सकते हो, राइट? सो द थिंकिंग डिस्टेंस विल increase because it is totally reliant on what the speed is. Time unchanged, but speed faster. Speed is equals to distance divided by time, right? And the shorter the time will be, the more distance there will be, right? So that's exactly how it is. It is explained by that. ठीक है ना? So two, state and explain the effect that the increase in speed and new tires have on the braking distance. First of all, there is an increase in speed and the change in new tires. So there will be, आपको पहले ही उन्होंने बता दिया है, पहले ही उन्होंने बता दिया है कि at a greater speed than 100 kilometers an hour, the total stopping distance is same. यहाँ 100 kilometers an hour पे था, यहाँ greater than 100 kilometers an hour पे है, right? So what does that mean? That means कि the force of friction is larger, मतलब between the, देखिए, इंक्रीज इन स्पीड आई है, न्यू टायर्स आए हैं, तो द ब्रेकिंग डिस्टेंस विल डिक्रीज. अगर आप दोनों को 100 किलोमीटर एन आवर पे करते हैं ना, so the braking distance of the new tire will be much less than the old tires because the force of friction on the old tires will be less than the force of friction on the new tires, right? That's why people change their tire. वरना लोगों को टायर चेंज करने का क्या शौक चढ़े? It's because that the tires की जो frictional force होती है that reduces, or it is harder for the tires to get a grasp of the ground and stop. Okay, that is it for this question. Let's move on. Question 7. Figure 2.1 shows a satellite moving at a constant speed in a circular orbit around the Earth. Circular orbit matlab it is subjected to centripetal force which will give us a resultant force towards the center. Speed is a scalar quantity but velocity is a vector quantity. State how a vector quantity differs from a scalar quantity. Both are required to have a magnitude, but the difference is the direction. Scalar quantity has no direction, while a vector quantity does have a direction. ये लिखा है here. As simple as that. आगे underline every vector quantity in this list. Vector quantity, distance is a scalar quantity, displacement is a vector quantity, force is a vector quantity, because displacement and force both have a direction, while distance, length, mass, time don't have a direction. Acha, see, there is a resultant force acting on the satellite, figure 2.1. I already mentioned it. It's towards the center, which is a centripetal force. Centripetal force होता क्या है? When an object is moving in a circular path, उसकी velocity जो होती है is in this direction, and when the velocity is constantly changing directions, that implies, for example, this is a satellite. अब इसकी velocity will be in this direction. So the velocity is constantly changing direction. That means the velocity is changing, and when the velocity is changing, that implies there is an acceleration. और जब there is an acceleration, that means there is a resultant force, and that resultant force is always towards the center, और इसको बोलते हैं हम लोग centripetal force. ठीक है ना? So let's exactly what I told you. Direction of motion is changing, velocity is changing with time, or it is accelerating, which requires a resultant force. अच्छा आगे पढ़ लेते हैं. State the cause of this force. This cause of this force होगा gravitational field strength. Very obvious answer. So that is it for this video. I hope you enjoyed. Thank you for watching. Allah Hafiz.